I want to start off by going over number 18 on your study guide one more time, and then we have a couple other practice problems. So number 18 on the study guide says Miss Smith can burn 225 calories by running 3/4 of a mile. If Miss Smith ran half of a mile, how many calories did she burn? So to do this problem, I'm actually going to draw a model. I'm going to represent it using a box, or what we call a tape diagram. This is sort of going to represent 1 mile. And then I'm going to have to represent 3/4 of a mile. So there is 3/4 of a mile, which is 3/4 of my entire tape diagram. I'm going to go ahead and sort of shade that off so that we know exactly what Miss Smith ran was 3/4 of a mile. Then I'm going to label how many calories she burned. She burned 225 calories. And I'm going to draw these lines to represent that she burned those 225 calories while she was running this 3/4 of a mile. This visually helps me see the problem and where the numbers fall. From here, it's a lot easier to solve than just looking at the words of a problem. So now if I have 225 and I'm looking at my diagram, my question is, how many calories did Miss Smith burn in 1/4 of a mile? So what I'm doing is, I haven't figured out the answer to the question yet. I'm taking a slightly smaller question, and that way I can get to the answer I need. So the first thing I'm going to look at is how many calories did she burn in 1/4 of a mile? Well, that is 3/4 of a mile. So what I need to do is I just need to do 225 divided by 3. That would give me 75 calories. So I'm going to go back to my model and write in my 75 in each of the 3 boxes. You don't have to do this problem with the model, but I like this way of thinking about figuring out how much she ran in 1/4 of a mile first, breaking it down into just a smaller piece. So 1/4 of a mile was 75 calories, but we wanted to figure out how much was 1/2 of a mile. For my drawing, I know that this right here would represent 1/2 of a mile, and that would be 150 calories. I like the idea of a model, because from the model, you can answer a lot of questions. You could have answered, how many calories will she burn in 1 whole mile? How many calories will she burn in 2 whole miles? There's a lot of different ways to think about this, and I think the visual representation really helps those visual learners. If you're not on the visual learner side, then I would start by trying to figure out how many calories she burns in 1/4 of a mile, and then build up till you get to 1/2 of a mile. Let's do a second problem. Feel free to pause the video, solve it by yourself first, then watch as I solve it. Sarah has done 3/4 of her homework. If she has 2 hours of homework, how long has she been working on it so far? Again, I'm going to start by drawing a model. So I know that this entire mile is 2 hours of homework. But she hasn't done all 2 hours of her homework yet. That would be half. That would be 1 hour of homework. But she's done more than half. She's done 3/4 of her homework. So if I'm looking at 3/4, that would be 3/4. From the entire 2 hours, this would be 1.5 hours. I took my entire 2 hours, and I could say I need to divide my entire 2 hours, divide it into 4 equal sections because of the fourths. That would give me 0.5. Then I need to multiply my 0.5 times 3 because it's not 1/4 1/4 of an hour, it's 3/4 of an hour. And that would give me 1.5. Now, another way of looking at this problem, if I needed an equation, would be I could have done 2 times 3/4. And that would have given me 1.5. Frequently, we skip right ahead and do 2 times 3/4 because of this keyword of. The keyword of means multiplication. So sometimes looking for keywords can be helpful. But it's important to understand why. What I'm doing with this 2 is I like to think that first I'm going to divide it by 4 and then multiply it by 3, which is exactly the same thing as multiplying by 3/4. I have one more sample question. Jeremy sold 5/8 of his baseball cards. If he sold 50 of his cards, how many cards does he have left? Now, this is a slightly different problem. This number right here is not the total number of cards he started with, but the part of cards that he sold. Okay, so in this problem, they're giving you the part. Let's go back. In this question, did they give you the part or did they give you the whole? They gave you the whole. A lot of times when we see the word of, we automatically think of multiplying, but we need to be very smart when we read these problems. Yes, the whole number times the fraction is going to equal the part. But if you're given the part, you're not going to be able to multiply. You could have multiplied 5/8 times whatever number represents the total amount of baseball cards, and that should give you 50. We'll solve problems like that later on with algebra. For right now, I want to start off by doing a model. So I'm going to draw a large shape diagram, and I'm going to say he sold 5/8 of his baseball cards. So I know that I need to split my diagram into 8. Then I go through and I represent by shading 5/8 of them. 1, 2, 3, 4, 5. That's 5/8 of his baseball cards. Now, the 50. I'm going to label the 50, but I'm going to be very specific. The 50 just represents the amount that he sold. Remember, the entire tape diagram represents all of his cards. So, let me go ahead and label that. All of his cards are all of them right here. These are just the ones he sold. Now, from my diagram, I can figure out what do I need to do. If I have 50 cards and I have how many boxes? 1, 2, 3, 4, 5. I'm going to go ahead and say 50 divided by 5, which is 10. Now, I need to figure out how many cards does he have left. I'm first going to figure out how many cards did he start with. He started with 80 cards because I did 10 times 8. Another way of doing this problem would be to do 50 divided by 5/8. Remember on the last question I showed you an equation and I said it's a multiplication equation? And I said because of that keyword of? I told you not to get tricked by keywords because you're going to see ofs in the problem. And they don't always mean to multiply. They do mean to multiply, but they mean to multiply. I viewed 5/8 of his total baseball cards, but we didn't know the total baseball cards, so we couldn't just multiply the two numbers together. This would be a division problem where I have to divide it into groups of 5 first, then I can multiply it by 8. Now, I haven't answered the question yet because it did ask for how many are left. Here are the number that are left. There are 30 baseball cards left. If you would like some more practice on these type of word problems, I recommend going to the Thinking Blocks website. Thinking Blocks has a series of activities on fractions and word problems that help you visualize the problems. You can find the link on its learning or just Google Thinking Blocks fractions and you'll get to a whole bunch of interactive practice that steps you through how to model and label your models so that they can become more helpful.